right after lunch, and I promise we will keep it interesting. So this is a design session dealing with service-centric cross-cloud network. And I am joined here by a few of my fellow speakers, Satish Kondalam, who is a solution product manager for cross-cloud network, Payam, Kohan, and Steffen, Kreis, who are our esteemed customers, solution architects from two of the leading banks. And myself, Anoop, Vetteth, I'm a director of product management responsible for cross-cloud network. So before we get into this topic, I would like to do a quick recap of what we introduced last year at Cloud Next. Google Cross-Cloud Network is built on Google's planet-scale backbone, allowing our enterprise customers to consolidate their bespoke networks, allowing them to build distributed multi-cloud applications, deliver them over the internet, and also ensure high-performance, secure access for the hybrid workforce. We have over 5,000 customers using one or more of these use cases. Google Cross-Cloud Network is an open platform with a rich ecosystem of partnerships. It allows any-to-any connectivity between clouds, users, and services. It has best-of-breed embedded security. And last but not the least, high-performance connectivity that lowers your total cost of ownership. In this session, we will build on the first use case, which is the distributed multi-cloud applications. We will speak to you about a few customer challenges that we came upon since launch. We'll speak to you about some of the innovative solutions to those challenges. You will hear from a few of our customers on how they intend to leverage service-centric cross-cloud network to fix some of their challenges. And last but not the least, we also have a couple of demos that you can use to see some of these innovations come to life. So without further ado, let's get started. Let's start with why applications are getting distributed. Enterprises are increasingly moving towards a service-centric approach to application development, where the service owners build the service once that can be reused by multiple applications. It is not cost-efficient to run these services on every single cloud and every single platform. Secondly, we also see enterprises relying on best-of-breed SaaS services offered by cloud service providers or pure-play vendors. Again, you don't have the luxury to ensure that these SaaS solutions are available on every single cloud. Thirdly, AI is increasing this cross-cloud dependency. We see enterprises trying to maximize the efficiency of the available GPU, TPU resources that are spread across multiple clouds. Models that are most suited for the enterprise may require the enterprise to expand into a new cloud. And last but not the least, these models need to be trained. The data may not be co-resident with the models or the GPUs that are available to you. So now let's go into a few of the challenges. And before I go into the challenges, I would like to present a popular deployment pattern that we have seen across a lot of our customers. How do customers enable this cross-cloud connectivity today? Customers rely on a global landing VPC that provides a full mesh connectivity between workloads across multiple clouds, hosted in multiple regions, accessing services, again, across multiple clouds and multiple regions. This any-to-any connectivity is enabled via routing. I don't need to belabor the point in terms of the complexity in achieving high available architectures using a routing-based design. IP overlap across these heterogeneous environments just compounds the complexity and the challenges that you will end up facing. You can, of course, use network address translation or NAT but that has unintended consequences when it comes to security. Lastly, these environments are dynamic in nature. They need to adapt to changes that may be planned or unplanned. You need granular traffic management to be able to do progressive rollout, canary, A/B testing. And you also need the capability to fail over using active health check. And I don't know the last time you were able to do that using routing as a mechanism to do the failover. Now let's layer in security. The most common deployment pattern for security or network firewalls is multi-NIC firewall. These are appliances that basically straddle two security zones. They create unnecessary choke points and also drive up the operational complexity because they are also moonlighting as routers that share routes between the two security domains. We also see the desire from our customers to adopt additional security services like zero trust, data loss prevention, and service rate limiting. But these are, again, extremely challenging in a routed design. The current deployment patterns also create a web of dependencies between the different admin personas. The DevOps team are relying on the NetOps team to get their VPCs provisioned, get a set of IP subnets that they can use, and also enable routing. The NetOps team and the SecOps team jointly operate the multi-NIC firewall that we spoke about earlier. And thirdly, the security teams are now at the mercy of the application teams to provision the right set of policies in the application VPC. These interdependencies are resolved using manual ticketing systems that slow down or hamper the pace of innovation. Also keep in mind that these are not homogeneous environments. The applications span multiple clouds, multiple platforms, serverless, VM containers, and the services themselves can be cloud native, Google native services like Vertex AI, BigQuery, the partner provided services like MongoDB, Confluent, or self-managed services that you may have in your environment. Having custom integrations or connectivity and security policies for each of these permutations is not going to be scalable. So to solve all of these challenges, we are introducing service-centric cross-cloud network that simplifies how services can be published onto the network, allowing you to accelerate your application development. With service-centric cross-cloud network, you also get a consistent mechanism for connectivity and enforce security policies for any workload accessing any service from any cloud. Let's go into the next level of detail. Service-centric cross-cloud network is an opinionated deployment model with a set of innovations that enable it. Service owners can now be given an isolated, non-routable VPC where they can build their services. And in that VPC, they can use, or rather reuse, the private IP space. So prevent IP proliferation. The application development team can also use any platform of choice, containers, VM, serverless, you name it. Security teams can now use hierarchical firewall policies at the org level or the folder level to ensure that that isolated non-routable VPC conforms to the security posture of the enterprise. Service-centric cross-cloud network relies on Private Service Connect, or PSC, as a standard mechanism to publish these services into a global service landing VPC. PSE allows the consumption of these services at line rate performance with no IP coordination and shared resource dependencies with the network. Now we have a uniform mechanism by which you can access the services independent of whether the service is a Google native service, a partner provided service, or a self-managed service that you may have. The network team uses Network Connectivity Center, or NCC, to create a hub and spoke topology between the service landing VPC and the workloads that are spread across the different clouds and different regions. The workloads that are on other clouds connect into Google via interconnect, direct interconnect, partner interconnect, or cross-cloud interconnect. There are a couple of new innovations or new capabilities that enable the any-to-any connectivity via NCC shown on the slide. Number one, NCC with dynamic route exchange, where now you have the ability to have VPC spokes and hybrid spokes coexist on the same NCC. And secondly, NCC with PSE propagation now enables the reachability of the PSE endpoint or the PSE neg in the service landing VPC to the workloads that may or may not even reside on Google. But wait, not all services are created equal, right? Let me give you a couple of examples where the services themselves have external dependencies. A self-managed service that you may have may rely on a SaaS service like BigQuery. The second example is a very popular one. Customers use Apigee as the API gateway for their on-prem databases. So in these cases, that non-routable isolated VPC that we spoke about needs to reach back into the network. And for this, we recently introduced PSE interfaces. PSE interfaces provides a standardized mechanism for making this happen. It allows the non-routable VPCs to remain non-routable. It preserves the separation between producer and consumer, and still allows the producer VPC to reach back into the service landing VPC. So in this case, now the customer managed service has access to BQ because BQ is a service that is published in the service landing VPC. And since the service landing VPC is part of the routing mesh, Apigee can now access the database that may be on-prem. I'm going to introduce one variation to the design pattern that we spoke about. Here, there is a proxy load balancer or application load balancer that front ends all the PSE negs in the service landing VPC. All the connectivity patterns that we spoke about earlier, they all work seamlessly even with this variation. Why are we doing this? We spoke about the granular traffic management that is required for canary, A/B testing, progressive rollout. We also spoke about PSE being a regional construct and using active health check to fail over from region A to region B when bad things happen. So that load balancer provides the enforcement point to enable these complex use cases that you may have in your high available architectures. We covered a lot of topics here, and before I proceed, I would like to invite Steffen to speak to you about some of their challenges and where they see service-centric cross-cloud network.
I think that was, okay. Hello, everybody. My name is Steffen Kreis. I'm a cloud solution architect at Commerzbank in Germany. Before I want to show you the network design that we've been working on, want to briefly introduce Commerzbank. We're the leading bank in Germany for the German Mittelstand, with around about 11 million customers in the small business and private segment. Our business model focuses around growth, excellence, and responsibility. And one of the key factors I want to highlight here is that we have the idea of shaping a digital and sustainable transformation where Google Cloud and public cloud in general plays a crucial role. So what we've done over the time when we were on our cloud journey is we've developed a cloud zone model. So the cloud zone model for us is a confidentiality model which allows us to control and govern integration as well as isolation for network-bound services. Two of these zones you see here, the one on the bottom is treated as a data center extension zone where we host traditional services like lift and shift virtual machines or Google Cloud VMware Engine, which are fully integrated with our on-premise environment and work in the same manner. The zone above is intended for platform-oriented and network-integrated managed services, where we also host shared VPCs, use internal IP ranges, and place all these services inside there. So the services up there are fully integrated in the network. In order to control and govern the connectivity and the connection flow, we're using layer 3 firewall instances Anoop just mentioned from a pattern design, which are governing connectivity and routing as well. So the challenge here is for us that this model has worked initially quite well, but now as we scale out, we are seeing lots of problems. On the one hand, IP address management becomes a huge overhead. So we need to manage centrally IP ranges, give that out to the teams, shared VPC, shared subnets, but that tends to be quite quickly, especially with services that have a huge demand for IP addresses. Second is routing becomes quickly very complex. On the one hand, we're using non-RFC 1918 address space in the on-prem environment, which we propagate to the cloud, but also here scaling out makes routing with the different VPCs very, very complex, and it's not scaling the way we want. And lastly, IP address consumption, especially for, like I said, services like GKE, they are problematic as we scale, as well as private service access-based services from Google that tend to take away a huge amount of the IP address space that we give them just for reserving their next subnet. So we looked at that model, and now we decided how to move on and go forward. Because like these services in these zones, when we talk about topics like internet ingress or egress, they always need to be managed centrally at a central place because everything is network integrated with our environment, which becomes problematic and takes away a lot of flexibility from the public cloud. So what we now do, and we've started to build, is another, we call it zone, which is much more service-oriented. And in this service-focused zone, we no longer run shared VPCs, but we allow the DevOps teams to get on a project where they can deploy isolated standalone VPCs. That removes completely the need for IP address management because there is no VPC peering. We don't need to worry about IP address overlapping. They basically can reuse the IP address space Google is using from a private IP range. But when we want to connect to the service, because nothing runs detached and standalone, we're now using Private Service Connect endpoints where the DevOps teams have a single way of publishing the service, doing the service attachment as a service producer. And we, from a platform team, we use the PSC endpoints and place that in our landing tier, which is the way we govern connectivity. And we can then use a single IP address to make a service available, while the overall service, the GKE nodes whatsoever, they run in their isolated VPC, and we don't need to worry about the on-prem environment. So this is the way we're now publishing these services. Again, that's usually working quite well, but often the services, again, they can't live standalone, on a standalone manner there. They need to connect to different applications or even on-prem environments. So luckily, at Commerzbank, we're having an API-first strategy where applications provide APIs as API producers on our API hub on the API management platform. And also for this pattern, we're using private Service Connect endpoints at the moment, but this time in a reverse manner. So while on the producer side, when connecting to the service, the unidirectional way gives us a good capability to connect to the services in the upper zone in a secure manner. We're now using the same one, but in a reverse fashion, where we connect via the service attachment to the API hub, so that applications can then consume the internal APIs that we produce up there. For this use case, we are now also going to explore if private Service Connect interfaces is an option for us. Right now, PSC endpoints is the way we're using here. And with that, I would like to hand over to Satish, who's going to give a demo. Thank you.
All right, good afternoon, folks. I'm Satish Kondalam. I'm a Solution Product Manager at Google Cloud Networking team. So I'm going to actually talk about whether whatever Anoop showed is actually real or just slides. Right? So before I do the demo, to set the context, what I'm going to show you is a workload in other cloud accessing AML service in GCP. Right? And that specific service is Vertex AI. So using the constructs and the opinionated deployment models that Anoop showed, we're going to show you how we can use service-centric cross-cloud network to connect workloads in any cloud or on-prem to any service, especially AML services, in GCP. Okay? With that, let's see how we can do that. So the Vertex AI service that I'm specifically chosen is vector search. So what I'm going to do is go to vector search, which is in the Vertex AI, and deploy the vector search in two regions, namely US Central 1 and US West 1. So as you can see, I have the endpoints deployed. This one is in region A, right? And then I'm going to go to the other region, which is US West 1. I'm going to show you I have a vector search endpoint deployed there as well. And then with 4 steps, I'm going to show you how you can connect your workload to the vector search endpoint in Google Cloud. So to do that, and then the team spoke about it, what we are going to use is a private Service Connect. So then I'm going to go to the private Service Connect, which is under the networking services. And using the private Service Connect, I'm going to deploy 2 PSC endpoints, namely one connecting to the Vertex service in US West 1, other Vertex service in US Central 1. And to ensure that I have all the traffic management capabilities that Anoop spoke about, the service chain, the load, the failover, multi-region failover, and all of those things, I am going to deploy load balancer in front of that endpoint. As you can see, I have 2 load balancers that I'm going to deploy. These load balancers backend corresponds to the 2 private Service Connect endpoints or the next that I've deployed. And specifically, please note, one of the endpoint, which is the one that is in US West 1, actually has regional access or global access enabled. So that means that endpoint can be accessed from all other regions. That is going to be important in a minute. Okay? So again, to summarize, I have the endpoints. I'm going to create that. Then, as you can see, I have the cloud DNS, where I'm creating 2 forward zones or 2 forwarding zones. I'm going to map that to the proxy LBs that I've created in US Central and US West. Okay. With that, my connectivity within Google Cloud has been set up. Now I'm going to go ensure that using my interconnects, I can provide access from the other cloud to Google Cloud. And here, as you can go through that, you will see that I'm deploying the interconnect only in the US Central region. And using the PSC and the proxy LB, I'm going to ensure that the US Central region, the interconnect that is connecting to the other cloud, has access to both the Vertex endpoints. So as you can see, I have the interconnect up. I have my links up in there. Okay. Then I'm going to show you, if I go to the actual router, I'm going to show you that I have connectivity set up end-to-end. So what I'm doing here is I'm ensuring that my proxy LB subnets on Google Cloud is accessible to the other cloud, and the workloads in the other cloud is actually accessible to Google Cloud, so that I have bidirectional connectivity. And I'm going to do that both in the West region and the Central region. So with these 4 steps, I've ensured that I have access from the other cloud, which is AWS, the workload sitting there, into the Vertex AI service in Google Cloud. Now, I'm actually going to go to the workload. And on the workload, I'm going to do a gRPC call to ensure that I have connectivity to the Vertex AI service. So you see the first gRPC call is to the Vertex Central service, which is in Central 1. The second gRPC call is actually going to the Vertex AI service that is in US West 1. So that is how we ensure that the workloads in other cloud, very simple steps, and connecting to your ML service in GCP. Right. With that, I'm going to move on. So far, what we have been focusing on is how we can take your workloads, which is in any cloud or on-prem, and connect that to your Google service. So let's now flip that a little bit. What if your service is in another cloud? As an example, Splunk is a service, a very popular analytics service that's hosted in other cloud. How do you provide access to that? So the way the other clouds expose their service is to something called as private link endpoint. So what we can do is, and as you can see in the diagram here, on the service landing VPC, I can deploy something called as hybrid NIC, hybrid network endpoint group, and I can point that to the private link endpoint that is deployed in landing VPC of other cloud. In that way, I can ensure that the workloads in GCP or the workloads from on-prem, which are at the bottom, can actually access a service in another cloud. Now let's talk about a few other deployment models. What if you're using traditional services in routed VPCs? You have these traditional services that you have deployed in routed VPCs, which I'm showing on the right there, and you want to connect them into the service-centric cross-cloud network. We have a new feature called as cross-VPC backend to do that. So with that, what you can do is on the service landing VPC, with the proxy load balancers or the internal application load balancers you have, you can actually connect to the backends in a different VPC. So far, this feature was available only on our global external load balancers, where your backend can be in a different VPC. We are extending that to our internal application and the proxy load balancers so that you can set up your connectivity from a central point, which is service landing VPC. Your traffic management and security can be done there, but your backends, which are the services, can be in other routed VPCs. So that helps you simplify activity as well. So then to summarize, what service-centric cross-cloud network is an opinionated deployment pattern or a design pattern with a set of innovations to help you connect workloads from any cloud or on-prem to any type of services that could be Google native service, third-party service, or customer-managed service. With this, I'm going to introduce Payam from Scotiabank. So Payam and team have partnered with Google Cloud to figure out how service-centric cross-cloud network can help solve some of the challenges that they're facing. That.
Hello, everyone. Thanks for joining the session. The amazing thing to share this stage with smart people in here, now that you don't need to be a networking guy, now you know what is NCC, what is PSC, how to configure it, how to leverage it, right? So I'm going to go forward with the presentation with a quick introduction of who is the Scotiabank for the people and the folks in the room who are not familiar with the Scotiabank. So Scotiabank is one of the largest banks in Canada with a strong presence across Americas. We operate in more than 20 countries. We have and serve clients across Canada, US, Pacific Alliance countries, Brazil, Europe, and Asia Pac. And we serve and we have more than 88,000 employees to support all of our clients globally. And as you see, based on our footprint, based on our customer and the client that we serve, we have multiple data centers, and we are leveraging multiple public cloud to provide that connectivity to our client and services. So going forward, I'm going to go quickly over an enterprise who is leveraging the on-premise infrastructure to provide network connectivity services to their application, irrespective of where they're hosted. So in this example, the blue box that we have in the screen represent on-premises network infrastructure. And as any organization, when you start providing connectivity, we provide connectivity between on-premises workload hosted in a data center and a third-party external vendor services that you need to connect for your services. Those vendors can be anything that you use for internal enterprise services, or you use for providing services to your customer. And as a screen, that connection represents external service to on-premises that you need to go to your carrier. Depending on who is your carrier, it's going to take months, or depending on who you speak, it might be years to have that connection established. So as I go forward, with introduction of the public cloud, now the on-premises infrastructure is going to provide connectivity between cloud-hosted services, your modernized application, the on-premises hosted services, and a third party, which makes sense, right? So we have three-way communication. But the fun starts for architecture and engineering team in an enterprise with a multi-global footprint everywhere is when you introduce the second public cloud. So with the introduction of the second public cloud, now your architecture and engineering team needs to manage connectivity and making sure they can provide the same reliable connectivity through on-premises. And as you go forward, if you go toward having your application hosted in multiple public cloud, now you need to use on-premises, not just to provide the services as a transit, but provide the connectivity between services hosted in multiple public cloud. And keep in mind that with this change and this connectivity, now if there is an incident, if there is a failure in your on-premises infrastructure, it can actually impact your modernized cloud application. And I don't think anyone in the room believes that this is the best way of providing connectivity to your modernized application hosted in the public cloud. And depending on the organization size, as you go forward and add additional component, you will see how complex this network can become. With introduction of the additional data center, if your organization is same as Scotiabank, you have a global footprint with global diverse customers to provide the service, you will have more connectivity challenges, and your architecture team need to focus on how they can connect all the services with maintaining the reliability and become more fun for them as you add some regional services, because depending on the country you serve, there are some policies that some of the connectivity needs to be maintained within the region, which is, trust me, it's very fun. As you go forward, you can see that in this complex network connectivity, I haven't even showed the security features. Because as soon as you start talking about security, it's very important what type of data, what's the context of data, where the data is hosted, and you need to provide and apply those security services. And as you expand your hosting additional application in your public cloud, then you need to spend additional investment on on-premises services to maintain security and reliability for that connectivity. So now I'm going to go and say what we do in a Scotiabank, what we change in a Scotiabank with leveraging service-centric cross-cloud network with the help of the team in here that we've worked together with past 12 months in our account team to establish the new connectivity pattern and look at the network as a service. Because historically, when you have your modern application, we look at each application separately because of the options and the way that you can support the application. So as you go forward, in this example, the way that we're looking to a pattern-based architecture in Scotiabank, this blue box now represents the GCP networking fabric. And as we go on additional services, everyone starts with adding GCP workload for communication internally, and then you need to route between them. So far, it's easy. There was so much investment and innovation and a start of the public cloud to provide network services capability to native hosted workloads. And because of the migrations activity or legacy services hosted on-premises, everyone used interconnect to connect to on-premises services. So far, everything established, everyone has this architecture in their environment. What we have changed based on the new introduction of the capabilities as part of service-centric cross-cloud network is introduction of the new landing VPC, transit VPC. Internally, we call this CNC because NCC was taken by Google team. GCP. So we call Central Network Connectivity Service. We leverage this to look at network as a service, irrespective of how many projects you have, how many services they need to access. We want to make sure that we control and we adopt same pattern for any connectivity that we have. So the easy part is, as long as we're using Google services, the native Google services such as BigQuery and Cloud SQL is native. It's easy to provide that connectivity. Now we are going to look and see how we can address the challenge of providing connectivity between the public clouds. We didn't want to look at on-premises services or cloud exchange partner for that connectivity, because we need to rely on their capability for maintaining the health of our application. So we started looking at the CCI capability to provide connectivity with application hosted between public clouds to make sure that, first of all, we can have a predictive latency, and there's no other third party to provide that connectivity for us. We can maintain the service, and we want to make sure that it's a predictive connectivity path. The other advantage that we have that was a big win for Scotiabank, we leverage PSC for connection to other SaaS services hosted in GCP, such as Confluent Cloud or MongoDB Atlas. With this introduction and this pattern architecture, you can provide your services not just to hosted application in the cloud, but you can expose those services to on-prem connectivity. So basically, you revisit the way that you look at architecture as a network and look at a new way to provide that service for application. And the beauty in here is because everyone that I have on the screen using Google Networking Fabric, using software-defined network, we reduced the enablement of the service from months of enabling a circuit to really click of the button. As long as those party agrees, you can enable that service. This is going to improve and provide significant improvement to your application time to the market. As we go forward, this can also be leveraged for connectivity between different environments, different partners that you have in GCP. You don't need to have a private connection between them. You can leverage native GCP capabilities using PSC again for that connectivity. And at the end, if you have a use case that there is a enterprise share platform that does not need to require access to the VPC peering to all of the other projects that you have because of different nature of the application or LOBs, line of businesses using those services, you can apply the same pattern and expose only the service that's required to access and consume the data and the services that you have. So because we are looking now at a predictive architecture, and I can see everyone in the room that they like the idea, but I don't think they're happy because security still is not on diagram. So with the new capability the team has announced, now you can insert your cloud NGFW to protect all the services. So now you have different connectivity pattern, you have different profile, and different trust level. So on some of the services, you may need DLP capabilities. In some of the services, you want to make that policy based on the third party that you exchange data and SLA that you have between them. So with introduction of NGFW, you can achieve that. And Scotiabank looking to this pattern-based architecture to adopt all the services that I have in this screen. And to sum up, basically, all architecture is based on the PSC because it's providing modular connectivity. We use heavily the proxy load balancer for providing access or providing access to other third party to reach out to Scotia internal services, and CCI for any cloud-to-cloud application. With that, I'll pass it to Anoop to go to the next session. Thank you.
So thank you for a great segue here. We always keep the best for the last. Let's move on to security. At last Cloud Next, we launched in preview Google Cloud NGFW. This is a cloud-native, fully distributed, best-of-breed cloud firewall with 20x the threat efficacy compared to any other cloud-native firewall out there. We are happy to announce that this product is now generally available. Google Cloud NGFW can be seamlessly used with the service-centric cross-cloud network deployment pattern that we showed you today. But security spans beyond firewall. While protecting against known and unknown sophisticated threats is critical for the environment, we are seeing that our customers are trying to layer on additional advanced security tools to improve their security posture. How do I authenticate, authorize every single access to the service so that I have a zero trust architecture? How do I protect my sensitive data on those services? And how do I ensure that those services remain up and cannot be brought down by a denial of service attack? The proxy load balancer or application load balancer that we spoke to you about comes in handy here. The number one challenge in terms of adopting these security services has been lack of a centralized enforcement point and the custom integrations required for the security services. The proxy load balancer solves for both of those. Let's see how. So firstly, the application load balancer is completely integrated with the identity-aware proxy and the certificate authority service to allow every single session to be authenticated and authorized. And once the authorization is complete, the same proxy load balancer supports front-end MTLS, which we are launching in preview, to protect the session after authorization. Then this MTLS spans between the client and the load balancer. The backend MTLS between the load balancer and the service itself is work in progress and will be available soon. Let's move on to service rate limiting. We are also launching in preview the Cloud Armor integration into this internal application load balancer, providing rate limiting capability to all the services published in the service landing VPC. All the capabilities of Cloud Armor are now available to protect the services against complex web attacks, as well as to enable denial of service protections both from service rate limiting as well as client-side rate limiting. We are not stopping there. At the previous Cloud Next, we announced Service Extension, which is an open programmable data plane that allows you to insert SaaS services or your own customizations into workload data paths. This is exposed from our load balancers. Now you have the power of service extensions to all the services that are published in the service landing VPC. Service extensions span routing extensions for custom backend selection, security extensions to allow insertion of your choice of security service like API security, and last but not the least, traffic services so you can alter request response headers or do custom logging. As a proof point of what can be achieved with the service extension, we are also excited to announce data loss protection service from Broadcom Symantec integrated with our internal application load balancer to protect the sensitive data on the services within the service landing VPC. This solution allows you to classify your sensitive data once and manage policies and incidents from a central single pane of glass for your sensitive data that may be at rest in your storage buckets or in transit through that firewall or load balancer. For those of you who are in regulated industries and have resisted the migration of these sensitive services from on-prem, now you can do that while remaining compliant. So I'm going to invite Satish to close out the session with a quick demo on the DLP.
We'll talk about the demo of how we can insert your data leak prevention service into the whole service-centric cross-cloud network. So if you remember, Anoop spoke about, hey, you have your workloads, they're trying to access your service, you have a service landing VPC that you have deployed your proxy LB or your internal ALB in there, and on that, using service extensions, we can integrate, as you can see there, down there, we can integrate to a DLP, and the DLP is from Broadcom, right? So it's a very simple one-click integration where you take your LB and you integrate that into your, with service extensions to your third-party DLP service, in this case, Broadcom, Symantec. Then what I'm going to do is, I'm going to go into the console, and first, we're going to send a benign file. So using Postman, using Post, I'm going to publish a benign file through the network, and when I send that file, you will see since it's a benign file, your status is 200 OK, and the file went through. Okay? Now, let's introduce a file that has sensitive data in there, and let's say I post that data. The moment I do that, you can see the content is being blocked, and that's blocked because of the DLP policies. Right? So the content is actually not going through. All of these things are actually logged into the Broadcom DLP UI, because that's the solution that you're using. Right? So if you go into the Broadcom DLP UI, and I go to that particular ID, which is the latest file that I sent, on the left, you will see all of the things, right? Hey, from where attachment it is, from where it got detected, what was in the file, and the file that got blocked. And I can also go and check what was specifically in that file that actually got blocked. Okay? So with this, you can insert your DLP service transparently into the network, ensure your sensitive data is protected when workload from any cloud or on-prem is trying to talk to your DLP service. Sorry, talk to your services, any services in Google or third party. So with that, we are going to close it off. We ran out of time, so we might not have time for Q&A now, but the team is available if you want to come and talk to us, either here or outside. Thank you so much, and thank you for coming.